All right. So we have made it to the last problem of the test, the practice test. Farmer Dundee needs to enclose a rectangular pen for his kangaroos. He only has 750 feet of fencing, so he will use the 60-foot side of a barn as part of one side of the fence. Calculate the largest possible area of the pen and the dimensions that will produce this area. So this is some kind of an optimization problem. So I hope that means something to you. Optimizing a problem usually means we have a quadratic that we're going to be trying to find the vertex of the quadratic. Of course, we got to get there first. So let's start setting things up. Let's draw a picture. So here is going to be my rectangular pen, and we've got the barn over here. That's my barn. And that's going to be one of my walls. Okay, so that means I only have the barn. I've only got, that's in it 60 feet long, right? Okay, so the remainder is going to be x, and y. Let's call that x, and y. And there's also another complication, which you really have to read this closely, but it says 60-foot side of a barn as part of one side of the fence. It doesn't say as one side, it says part of one side. So notice my picture. Let me redraw my picture. Just to make this a bit more clear. Actually, I'll just do this. So if the barn is here, oops, sorry. If the barn is here, then what the problem is actually saying is that this length here is 60. Okay, and that means that the remaining length here, what is that? And that's the red length. That's going to be, let's put that in red. That's going to be y minus 60. Okay, so we'll see if that really matters in any way as far as actually doing the problem. But let's be, you do want to be accurate. So that's the accurate representation. Okay, so what else do we know about this? So we want to calculate the largest possible area. An area formula, since this is a rectangle, this is going to be, let me get a black pen. Area is going to be x times y. That's the area, all that. Okay. And what do we know about it? We don't know anything about it. So actually, what the problem here is we have too many variables. So this always happens in these optimization problems, and we need a helper equation. So our helper equation is going to be in the 750 feet of fencing. So let's move into that. So we know that the total fencing is 750 feet. Right? And the perimeter has got to add to be that 750 feet, okay? So we've got, let's just kind of go around. We've got x plus y plus another x. And then this last portion right here is going to be y minus 60. And all of that gets me 750 feet. Okay, so now simplifying, this is 2x plus 2y minus 60 equals 750 feet. And therefore, let's simplify. So adding 60 is 810. Okay, cool. So now we have a helper equation. we have a main equation, and we can do the standard trick, which is to solve the helper for one of the variables and plug it into the main equation. So if it doesn't matter which one you want to solve for x or y, I don't care. In this case, I think they're equivalent. So let's just solve for x. So that's going to be 810 minus 2y divided by 2 is x, and therefore x is, what is that, 405 minus y. And so we will plug that in to our area formula. Now, it's because I chose to solve for x, I have a function of y, so don't let that freak you out. But so this is now 405 minus y times y. And by the way, the question says what is the largest possible area, so keep that in mind. That's what I'm actually trying to do here. So 405 minus y, that's 405, or let's actually do this, minus y squared plus 405y. So that is my actual quadratic that I'm going to optimize. So I need to get the vertex. And again, if you want to draw a picture of this, now what we've got is you've got y on this axis and a on this axis, and you've got something like that. And so we're looking for that vertex point. So I'm also kind of keeping my eye on this the second part. It says, what are the dimensions? So I've actually got three things I'm going to find. I'm going to find x, I'm going to find y, and I'm going to find a. So part A wants a, part B wants x and y. Okay, so let's kind of find all of that stuff. So first we need the vertex. So negative b over 2a is negative 405 divided by 2 times negative 1, which is something inconvenient. What is that? That's positive. And I'm trying to decide, what do I want to simplify it, or do I want to leave it as a fraction? I don't know. Maybe it would be better to leave it as a fraction. But if we put it in decimal form, that's what you got. So that's actually one of my answers. That's that's x. No, sorry, that's y. That is y. That is y. Okay. That's my y value. So then my a value is going to be a of y. So a of 202.5, which I like to go to the previous version of a because it's easier to compute. I mean, this version, and y'all have seen me do this in class before, but that's 405 minus 202.5 times 202.5. So basically that's going to be 202.5 squared. So you can figure that out, whatever that is. You know what, I'll just do it. That is 41006.25. So 410,000, wait, sorry, 41,000. That is 41,006.25 feet. Is this feet? I forgot. It is feet. Square feet. And this is just regular feet. So the only thing we have left is what is x. And to get x, I'm just going to go back to one of my original equations. How about this one? So 2x plus 2y equals 810. So 2x plus 2 times 202.5 equals 810. This is going to be 405. So 810 minus 405 is also 405. And lo and behold, x is also 202.5. So to recap, the best thing we can do here is basically make a square. X and Y will be the same size. And, you know, that's going to also tell you this little dimension here, that's 202.5 minus 60, whatever that is, you know. Okay, so this problem, you know, it's a standard optimization problem, but it did have this difficulty that came about by introducing that little portion. Like a lot of times when you see a problem like this, you would have the full side, and I almost made a mistake there. And a lot of people would make this mistake. It's just making that full side 60, and then you'd have that x and y, and then your equation would be different, right? Your equation would be 2x plus y equals 2x plus y equals 750, rather than it's the one that we have. Right. Okay, so there you go. There's the test. And all the solutions.